Hello dear students, welcome back at your own channel Maths Mela. Here we are to discuss about the academics of grade 10 board, the mathematics part. Now let's start the day with some good thought, somewhat saying. So the today's saying which I got is, people may doubt what you say, but people will surely believe that what you do. Isn't it? Yes, it is correct. So this thought, how it relate with the today's condition? It is because everybody nowadays is what? Giving suggestion that don't do this, don't do that, do this, do that. But before doing this so many things, are they following in their own life? Yes or no? Definitely, if you will see me that I am doing some exercises, I am following the government's guidelines, then definitely you will also like to follow me. And on the other hand, if suppose just I am telling you get up early in the morning and start with somewhat yoga, but on the other hand, if I am not doing, I am getting late in the morning, not doing any kind of exercises, so will you follow me? Surely not. Okay, the same way, if I am not doing any exercises, if I am not doing any study and I am telling you that you do study, so in that way also it won't affect you at all. So if I want to say, or if you want to advise somebody that don't be out, so first you have to be in. If you want to say or suggest somebody follow the guidelines, then first you have to follow the guidelines. If we are suggesting to somebody that early to get up and early to rise, so before that we have to do these things. So whatever the good values we want to see in our friends, in our next generations, or in our followers, we have to follow first. So once again I am repeating the thought that people will doubt you whatever you say, but they will always believe whatever you do. So do the correct thing at correct time. Now come back on the academics part. Right now we are dealing with the chapter number 6, triangles. We have completed exercise number 6.1, 6.2, 6.3 and 6.4. Right now we will be dealing with the theorem part. Today we are going to discuss 3 theorems. The theorem number 1 is, if a perpendicular is taken from the vertex of a right angle in a right angle triangle, then the formed two triangles are similar to one another, even each small triangle is similar to the bigger one. So let's go through the diagram first, how it is. Now this is what my right angle triangle. So it is A, B, C, and this is what my perpendicular I have taken, that is what BD. Okay, now due to this I have got two triangles, triangle number 1, triangle number 2. What the theorem suggests us, triangle number 1 is similar to ABC. Triangle number 2 is also similar to ABC, and then triangle number 1 is similar to triangle number 2. Okay, this we are going to prove. How it will be? If you are not okay with the diagram, you can just rotate it so you can be easily able to see how it will be. The same diagram, A, B and C, and this is what your AC, and then this is what your 90 degree. That is D. And then any triangle you can consider triangle number 1. And then any triangle, triangle number 2. What is given in this? Given BD is perpendicular to AC. Second thing is angle ABC is equal to 90 degree in triangle ABC. What to prove? to prove triangle number 1 or triangle ADB is similar to triangle ABC, where this is what 90 degree. First thing. Then second thing is what? Triangle ADB we have seen. Now triangle CDB is similar to triangle CBA. And third thing is what? Triangle ADB is similar to triangle C. Okay, DB. This we are going to prove. So let's go ahead with the first part. Okay, that is proof of first. That is in triangle ADB and triangle ABC. What we can see, observe it. ADB, angle D is what? 90 degree. ABC, angle B is also what? 90 degree. Right? So what we can say, angle ADB is equal to angle ABC. Why? Both 90 degree. Okay. Now what else you can see? Can you observe this angle A and angle A? This is nothing but this angle, which is what? Common in both the triangles. So what we can say is angle, say DAB is equal to angle BAC, which is what? Common. Now in two of the triangles, two angles are what? Equal. So therefore what we can say, therefore triangle ADB is similar to triangle ABC by double A rule. Right? Now similarly we can prove that here, if this is equation 1, similarly we can prove the second one, that is triangle CDB is similar to triangle CBA, again by double A rule. Right? Because C and C are what? Common. So in this one, angle C is equal to angle C, that is what the common one. Then angle B and angle B. Sorry. In this one, angle C and angle C are what? The common angles, and angle D and angle B are what? 90 degrees. So both are what? By double A rule. And again the third one can be obtained from 1 and 2. Since one triangle is similar to the ABC, second one is also to ABC. So it means what? Both are what? Therefore triangle ADB is also triangle 2 similar to triangle CDB. Right? Now with the help of this theorem we can solve some of the problems in the next exercise. But before solving that, let's go ahead with one of the favorite theorem, that is Pythagoras Theorem. Pythagoras Theorem you might have already learned in grade 6 and so on, because right from grade 6 you are using Pythagoras Theorem, but only the application part, proving part you have seen in grade 9, and with the help of similarity how to prove it. Okay, so let's go through the statement first. So what is the statement of Pythagoras Theorem? If in a right angle triangle the square of hypotenuse is equal to the sum of squares of its height and base. So again observe these two diagrams only. With the help of this triangle only we are going to show. So the same diagram you can use. So I am also using the same one. This is what the diagram, where I am writing A, B and C. And 90 degree, that is D. So what we have to prove that, or first let us write down given. So angle ABC is 90 degree in triangle ABC. After that what we have to prove, or what is else given, that is BB is perpendicular to AC. What to prove? prove that AC square is equal to AB square plus BC square. Okay, this we are going to prove, AB square plus BC square. Okay, now how to prove it? Again, since we have taken a perpendicular and we know that triangle number 1 and triangle number 2 will be what? Similar. Okay, so solution. Now let's go ahead with the proof part. One more time I will recall the statement. The statement of the Pythagoras theorem is the hypotenuse square is equal to the sum of its height square plus base square in a right angled triangle. Okay, by using similarity we are going to prove this. How? So let's go on. Solution. Since BD is perpendicular on AC, therefore triangle ADB is similar to triangle ABC by double A, or by that theorem simply you can say. Now since these two triangles are what? Similar, so we can just identify the two identical sides AB and AB, means we are going to use it double. So first we'll write AB upon AB and then is equal to this AB upon this AC. So what will happen here? AB into AB, it will become AB square, and then AC into DC. AC into AD. Okay, this is equal to what? AB square, equation number 1. Similarly, we can say that triangle ADB we have chosen, so now CDB is similar to CDB, so CBA again by theorem. Okay, and again since these two are what? Similar, CDB is similar, so what we can say, their corresponding side CD upon CB is equal to CB upon CA. Okay, so here CB is what? Coming double, so AC into DC is equal to AC square, equation number 2. Now we have equation number 1 as AC into AD is equal to AB square. Equation number 2, AC into DC is equal to AC square. So what we can do now, add 1 and 2. So what will happen? AC into AD plus AC into DC is equal to AB square, and then here it will be BC square. Okay, right? BC square. So what will happen? Take AC common, then AD plus CD is equal to AB square plus BC square. Now AC will be as it is. What is AD plus CD? AD plus CD is nothing but your AC only, and then this side is AB square plus BC square. And now AC into AC is what? AC square is equal to AB square is equal to BC square, which we have done, completed. Okay, this where we will use it or needing, that is AC square is what? The hypotenuse square is equal to the square of the sum of the remaining two sides. This is what your Pythagoras theorem. Now the Pythagoras theorem is also has a lot many use of solving the sum. Means many sums can be solved by using Pythagoras theorem. To solve exercise number next, that is 6.5, we are going to use theorem number 1, where we have to see that if a perpendicular is taken from the vertex of the right angle to the hypotenuse, then the new two triangles which are formed are similar to one another, or they are similar to the bigger triangle. By using this theorem, we are going to solve some problems. Then the next one is what? Pythagoras theorem, in that the hypotenuse square is equal to the square of its height and the square plus sum of the height square plus base square. Okay, in a right angle triangle. So these are what the two important theorems. Now the next theorem, which is known as the converse part of the Pythagoras theorem. Now what is converse part? It means that the reverse of it. What is given here in Pythagoras theorem? In Pythagoras theorem, it was given like this. In a right angle triangle, the square of hypotenuse, means already it is given that the triangle is right angle triangle. And the providing condition what we are going to prove is what? In a right angle triangle that is provided. In that right angle triangle, the square of hypotenuse is equal to the sum of square of its height and base. Means this we are going to prove. Right angle is given and we are proving the addition. Okay. But in converse part, what is given? Check it out. In this it is given that if in any triangle the sum of in any triangle the square of any one side is equal to the sum of squares of remaining two sides. If this condition is there, then that triangle will become a right angle triangle. Okay, so this is what the converse part, where we are going to prove the triangle is what? Right angle or no. How to prove? Three sides will be given to you. You have to choose any one side. Of course, it will be the bigger one. So the square of the bigger side, the longest side, the square of the longest side, if it is equal to the sum of the square of the remaining two sides, then whatever the triangle is, that triangle will become a right angle triangle. So this is what the converse part of Pythagoras theorem. This year we are not going to consider the proof of this because CBSE recently has reduced this one from the syllabus. Only the proof part is reduced, but the application part may come. Okay, so this is all about the three theorems, and I would like to give you home fun as exercise number 6.5, question number 1, where you just have to identify by using Pythagoras theorem, are there is right angle triangle or no. So question number 1 of exercise number 6.5 I am giving you for homework. Now let's wait for let's wait for another video at your own channel Maths Mela. Till that time, keep happy, be at home and be safe. Thanks a lot.